Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Krisna Nindya Kambara from Dian Nuswantoro University, Semarang. I'm originally from Bati, in the province of Central Java, and currently in my fourth semester. In this video, I would like to present my largest project so far that has the title of Semantic Auto-Suggestion Search Engine System for academic purpose. Fun fact, this project was came from a project class, and my contribution in this project was to implement pretend model named BERT for the task of next sentence prediction on knowledge graph ontology. I also contribute about 500 line of codes, and currently this project is still in development. So, did you know, when we trying to search something in search engine, we often encounter various ambiguity results from search engine itself. For instance, when we trying to search deep learning is, the results may become deep learning is B or deep learning is A, which is not what we wanted. Because of that, the users or we should specify and filter out the suggestion. Thus, the relevant knowledge is missed. So, for this project, his goals to build a deep learning model trained on a paper-based data as accurate as possible and as precise as possible. Also, we want to accurately generate meaningful word suggestion so that the user is satisfied with the results. And to improve the relevance of academic search results or academic writing. So, for the technical challenge, it was quite challenging for me because it is my first step to implement deep learning method on real-world cases. Given the combination of knowledge graph and BERT, we aims to create machine or model to be able to understand contextually and semantically by its meaning, not just keyword. The question was, how can we teach machine to learn semantically and contextually like human likely would? To answer this, I've decided to create my own dataset using web scraping technique and create thousands of sentence for next sentence prediction. So for the solution, I'm using BERT because BERT is deep learning model that has been able to understand the sentence meaning and context. And also, I'm using knowledge graph because it provides the structure of knowledge and factual relationship between academic topics. Then, the combination of knowledge graph and BERT, it can be predict semantically relevant next sentence. So, here is my system architecture. For the given component, here is BERT or next sentence prediction to be able understanding sentence context and accurate and flexible for NLP tasks. Then I'm using knowledge graph to store structure sentence and limit the suggestion to be less random and more focused on the topic, so that the results are not random and more focused on the topic. Given the combination of BERT and knowledge graph, it can be predict structure prediction and generate targeted semantic sentence suggestion. So, the power of knowledge graph and BERT. Why we combining knowledge graph and BERT? First, because it can be reduce randomness in suggestion. Without knowledge graph, the results or the output it can be more generic or irrelevant, which I mentioned before. Second, because it context-aware prediction. Even if there is two queries with the same prefix, this model or the knowledge graph and BERT will generate different prediction depending on the context. Thirdly or last, it can be mimics human-like reasoning. Combining knowledge graph structure facts and BERT language understanding helps simulate how human relate concept when searching. As you can see, for the given picture on the left, it is traditional search engine. For the given input of deep learning is commonly used for trans, the results it is random and in our perspective, it is ambiguous. On the right side, it is our model deployed onto the Streamlit. For the given input, it is deep learning is commonly used in for the prefix of trans. This model able to understand what the input it is talking about. In other words, it is in other words, this model knows what the input is talking about or contextually understand. As you can see, for the given input, it is the same, but the results may become different. So, from concept to reality, early demo. For the given sentence and its prefix and what expected suggestion for. As you can see, on the left side, it is traditional search engine. As you can see, the results it is know what the keyword. It can only predict what the keyword is. As you can see, at work. But in prefix, in expected suggestion, it is transfer of learning, transformation, and so on. In our model, for the given input of deep learning is widely applied in. For the prefix of trans, the results may become what we expected for. For instance, it is transfer of learning. So for the behind the build, I'm using MacBook Air M2 as development environment as local. For the CPU of Apple M2, and for the operating system, I'm using macOS Sequoia. Then from the cloud training, I'm using Kaggle and Colab. First, I'm using Colab because Colab I only use for the data analysis, data exploratory, and so on, except training and testing. Because what? Because I only using training and testing for Kaggle. Why? Because Kaggle is super strong runtime because it can be run on the background. So that we shut down the device on our device, it can be run on the background. So for the GPU, I'm using NVIDIA Tesla T4 NP100. And for the RAM, it is 12.5 up to 29 gigabytes. So, and for the additional requirement, I'm using pre-trained model Leopard. For specify task, it is next sentence prediction, PyTorch, Streamlit, and Hugging Face or Hugging Face Hub. So here's my interesting part. It is model design. I've mentioned before, I'm using web scraping technique on each paper's DOI. Then I store it into paper database. For example, P0047 store into TXT file. This database consists of thousands of papers stored into TXT file. Then for the each paper, I pre-process and cleaning text data. Then we prepare model. For the model, it is BERT NSP. Then the model or BERT process sentence for pairs for NSP. For instance, sentence A and sentence B, whether it's next or not next. Then for the next sentence prediction, sentence pairing. For the sentence pairing that has been paired by BERT NSP, we convert data into NSP pair CSV file. For the data that has been converted, we fine-tune data into BERT and next sentence prediction. Then the fine-tune data, we save model into Hugging Face repository. Let's move on the knowledge graph construction. For the input, there is paper database. Then for the its papers, I extracted its metadata. Then what we extracted for it is title and concept. Then for the extracted metadata, I creating triples like head, relation, tails. For instance, a title has topic of concept. Then we save triples into CSV file. Then for the final design, we prepare triple CSV and fine-tune model from Hugging Face, which I mentioned before on the model design, and knowledge graph construction. Then we extract candidate concept from knowledge graph. For instance, it is user query context plus prefix. Then for the rank candidates using PERT NSP. Then the candidate score for contextual relevance. For the candidate has been scored, we filter high scoring suggestion. To be more precise, I only filter top 5. Then the filter that has been high scoring filter suggestion, we deploy it onto Streamlit for the title of semantic auto-suggestion. So here is my project results. On the top left, it is demonstrating contextual relevance. As you can see, for the given input of deep learning is commonly used in for the prefix of trans, this model has been able to understand what the input is talking about. Then let's move on the right side of top. It is semantic understanding in action. As you can see, I've mentioned before, I only filter top 5 high scoring suggestion. As you can see, for the high scoring, it is up to 99%, and the lowest it is 49%. As you can see, for the bottom left side, I'm using knowledge graph as rich source. Then on the bottom right, it is fine-tune model per NSP. Before I deployed the combination of BERT and knowledge graph, I deployed first the fine-tune model per NSP. As you can see, for the given input of sentence A, it is quantum computing relies on the principle of superposition and entanglement. And the sentence B, it is these properties allow quantum system to process multiple possibilities at once. Then we click off button of prediction. The results may become sentence B is next to sentence A with the confidence of 99%. So here's my areas for improvement. Which I mentioned before, I only extracted each paper's metadata, the title, and concept. Because of that, it is limited graph coverage on academic concept. From evaluation results, it is accuracy 83%, it is high, but the recall may become 77%. Because of that, this model it is insufficient semantic diversity. From the confusion matrix, from the BERT model NSP that has been fine-tuned, as you can see, for the false negative is quite pretty high, up to 39,000. Because of that, we want to reduce suggestion ambiguity. So here's my future work. We want to toward a scalable and semantically accurate real-time auto-complete system. In this current model, it is BERT NSP model. But this model, from the evaluation matrix before and confusion matrix, it is quite pretty high from the recall, and low from the recall, and high on the false negative. Because of that, we want to create data augmentation and semantic pair expansion. After that, we want to optimize model using technique of quantization, pruning, distillation, and distillation. And what we expected for this action, we want to create model of BERT NSP or next sentence prediction that has been fast and efficient. Let's move on the knowledge graph. Current knowledge graph. It is limited and static. Then because of that, we want to create automated knowledge graph enrichment via relation extraction. After that, we want to create entity linking and disambiguation so that the knowledge graph is rich enough. So what we expected from the action, we want to get knowledge graph that has been dynamic and comprehensive or expanded. For the model that has been optimized and knowledge graph that has been expanded, we want to merge it to real-time system so that we can test it into real-world cases like traditional ones. So Thank you for listening for my presentation. I hope this presentation has insightful for you. I apologize if there is any mistake that has been I presented before. Thank you. Bye bye. See you next time.